I've got 5 problems here related to combining uncertainties with one another, and I'm going to go through the solutions to these problems here in this video. It might be useful for you to pause right now before I do that and try these for yourself. That way, it'll help you learn better and reinforce what you already know. So I'll give you a second to pause, and then I'm going to go ahead and start solving these problems. Okay, starting with question A. And I wrote them here in blue so I don't have to flip back to the other sheet. So this one here, looking at A, is just a simple addition problem. It's just got some decimals here, so you probably will have to use your calculator in this case. But just like other problems, we can add these two values together, and then since it's a simple addition, we just add these two values together. So simple enough, we just take 16.45 plus 9.73, which gives us 26.18, plus or minus 1.3 plus 0.8, which is 2.1. And don't be afraid to use a calculator. I did not do this in my head, so it's fine to use a calculator to calculate this. I did these ahead of time, so don't be worried about that. All right, question B. So this is also, we've got a simple addition here, but we also have a subtraction. So we're looking at a problem that has 3 terms. So how do we go about doing this? Well, it's exactly the same. We just have 3 terms. So we take, I'll write it out this way. We have 12 plus 7.7, and then we can subtract by this value, minus 11.6. Then plus or minus the uncertainty values, we add those together. So 2 plus 0.9 plus 1. And recall that with these uncertainty values, even though we're subtracting here, we still add the uncertainty value. So this works out to be 8.1 plus or minus 3.9. Or I'm going to round this uncertainty value to be 8.1 plus or minus 4. And that is the answer for B. Okay, how about C? Well, C, as we can see, is a multiplication problem, and we only have 2 terms. So we can multiply these together, and then we need to find the relative uncertainty, because for multiplication and division, we need the relative values. So 36 times 18.74, if you put that in your calculator, that is 674.74. Then we can find the relative uncertainties by taking this 3, dividing it by its value, and then we add, as we always do with uncertainties, 1.3 divided by 18.74. And then I'm going to also multiply by this value again, just to get it in its relative form. Or its, sorry, the opposite, in its exact form. If you left this out, it would be, the uncertainty would be quoted in its relative form, which is also a valid way. I'm just doing this because I like it in its exact form. Okay, so this turns out to be 674.74, and I'm going to run out of room here, plus or minus 103.04. Now there's kind of a lot of decimals here, so I'm going to round to 675. We round this up, plus or minus 103. And that's what we get for question C. So now moving on to question D, we have some scientific notation action going on here. So how do we want to go about doing this? Well, first of all, we notice it's, again, just a multiplication of two values. So we go about it in exactly the same way. It's just the numbers are written in different forms. So we can I'll just write it out explicitly here. We take 1.2 times 10 to the 3, and we multiply by 7.2 times 10 to the 2, plus or minus. Now since it's multiplication, we want our relative uncertainties, so I'm going to bracket this, and we take 3 times 10 to the 1, divided by 1.2 times 10 to the 3. Then we add 1 times 10 to the 1 over 7.2 times 10 to the 2. And then I'll multiply by this again. I'm not going to write it out, but multiply by this on this side to get your exact value. And if you put this in your calculator, you'll get 8.64 times 10 to the 5. And then if you take this times your value, you will get you'll get 3.36 times 10 to the 4. So that's this times this multiplied by this whole term here. Okay. Now again, we have lots of decimal places here, and we may want to round. So I'm just going to take this to one decimal place times 10 to the 5. And this one I'm just going to say is 3 times 10 to the 4. There are rules for the number of decimal places you can have for your uncertainties relative to your actual value. And I'll be talking about that coming up in the next few videos. But for now, we're just going to round it like this, and you'll have to trust me on it. So this is a perfectly valid answer. If you want to write it out in its integer form, it would just be 864,000 plus or minus 30,000. And so writing it that way, you can see why scientific notation is much preferred to this. This just takes time, and it doesn't look as good, at least in my opinion. Okay, and finally, question E. So this one, we have a combination of two operations. We have a division and we have a multiplication. So the best way to tackle one like this would be to break it up. So let's handle the division first and then the multiplication. So I'll write it out. So we can divide the 24 by the 6. Then we find our relative uncertainties, 2 over 24 plus 1 over 6. And then again, as I've done in the other examples, I'm going to multiply by the value to get our exact uncertainty. And I'm going to put big square brackets around it and carry this term here, just so I remember it. It's easy to go through a calculation and forget that you have another term that you're going to do. So it's always good to write out every part of your equation. So 24 over 6 is 4, plus this is 4, and then this ends up working out 2 over 24 is 1 over 12 plus 1 over 6, and that will give you, that'll work out to 1/4. So we've got that, and then we'll carry this term again. So as you can see, these 4s will cancel. And now we just have 4 plus or minus 1 times 4 plus or minus 1. And now it's a simple multiplication problem, and it actually worked out I didn't intend it to work out this way, but they're the same values. So simple multiplication, we multiply these, and then I'm just going to multiply that. And then we get our relative uncertainties, which are both 1/4, which works out to, just to be very explicit here, 1/2. And that, of course, is 16 plus or minus 8. So that's kind of a large uncertainty there on that. Whoever did that experiment didn't do a very good job. So those are just five problems. Hopefully they were helpful. It's good to practice. Maybe even come up with your own problems if you're. That's a good way to learn. And yeah, hopefully that was helpful, and I'll see you in the next video.